check, 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 check. Sound Venus. Check, check. Amute. Oh, check, check, check. Then check, check, check one, check, 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 check. No, ready, ready, ready. On the time, ready. Check, 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 check. දැන් බලන්නකො පොඩ්ඩක් පිටිපස්සට ගිහින් check one, check. Check, check. Mati, mati, අමාරුයි. Check, check, check. Sound එක වැඩි. තව පොඩ්ඩක් අඩු කරා. තව වැඩි කරා. තව වැඩි කරා. Shape. Check, 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 check. Online students, can you hear me clearly? Online students, can you hear me clearly? Online students, can you confirm if they can hear me clearly? Okay, thank you. And like, I hope everyone got the tunes, but the tunes will be available again in the WhatsApp group. Please check the WhatsApp group. And for the people who are not in the WhatsApp group, the tunes will be available in the Zoom chat. Then ready then. Well, and YouTube live students, just give us a confirm whether you can hear us clearly and if everything is okay. And I think for YouTube live students, you can find the tunes in the YouTube live description and again in the WhatsApp group. Tunes will be available for all the physical class students. There you got tunes. There you got all the tunes. Check, check, check. If anyone don't have the tune, just let us know. That was- Sure, for online students, tunes will be available in the Zoom chat within minutes. Okay. Uh, okay, so hope everyone can hear me clearly. I think reduce the sound a bit. Reduce the sound. It's too much. It's too much. Yeah, sure. You can hear me clearly? Malita doing on. You can hear me clearly? It's too much, right? Already. Yeah. Now, what about now? Okay, good. Can you hear me clearly? No. Yes or no? Yes. Yes, clearly? Yes. What about you? Okay. I mean, physics is already difficult, so you don't have to, I mean, you don't need to go through this trouble like hearing a very difficult voice. Okay. Anyways, I think we are good to go. I think online students can hear us clearly, and the tunes will be available in the Zoom chat only. Tunes, tunes will be available in the Zoom chat, and for anyone who don't have tunes, I'll give you a mobile number so that you can contact them. Tunes are available in the group. Tunes are available in the group. Yeah, so if you need any technical assistance or if you need any help or if you can't find the tutor, if you have any kind of issue like that, you can contact the number not 70402, not 70402 9701, not 70402 9701. You can contact this number if you need the tutors or Zoom links or anything like that. I think ACs are not in 19, right? Oh, yeah. Okay, we'll start the class. So I think there were some technical difficulties. That's why it took time, and I just waited until everyone come here because today we are starting the first lesson. Today we are starting the first lesson, units and dimensions, and the paper class plan. The paper plan has been changed a bit. I think it's a little bit inconvenient for everyone. I mean, yes, we'll arrange some other time slots too. So we are coming up with a new plan for you guys for the paper. If you can come, I mean, if 1 hour before the class, if it is possible, maybe until school starts at least, or maybe, I mean, for the people who can't join at that time, we'll arrange some other time slots. But if you can come before the class, 1 hour before the class, we can arrange the paper here 1 hour before the class. Then we can give you the marked papers, marks, and everything by the end of the class for both online and physical class students. So I think it would be convenient so that you don't have to come 2 days, so and you get all the marks at the end of the day, and it's quite convenient for everyone, I think. So if possible, from next week, yes, next week, from next week, it's definitely happening. For others, for the students who can't come to the class at that time, I'll arrange some other time slots. But for the majority, the best plan is you can come, like the class is starting at around 3, right? Yeah, class is starting at 3. So if you can come around, come to the class around 2 or maybe 1:30, we can let you write the paper for the people who need a half an hour break, 1:30 to 2:30. For the people who don't need a break, 2 to 3, 2 to 3. Then we can start the class. We can start the class, and at the end of the day, soon after the class, I mean, I'll be having my panel from next week onwards. So we can mark your papers within the class time for both online and physical class students. Then at the end of the class, you can get your own marks. So I think it will be really convenient, and I mean, it saves a lot of time for you guys, and it saves a lot of trouble. I mean, I know like some students may feel like, I mean, this is unnecessary. We are going through a lot of trouble. It's too much than O levels. Yes, A levels is already too much than O levels. And it's, I mean, the more trouble you have at the beginning, the less trouble you have at the end. That's how A level works. Okay. Okay, so if whatever the class you go, if it is really smooth, if you understand everything, okay, if the questions are really easy, if it makes you happy, that means you're gonna cry at the end of the day when it's too close to A levels. That's how A levels work. Okay, so at the beginning we should go through all the problems, writing papers, all the hassle, writing difficult questions, going through all the difficult stuff. If you can go through all the difficult stuff at the beginning, then at the end, we are really happy to move forward. Okay, I mean, that's what happened for me. As I said, I finished A level physics syllabus 1 year before the exam. For me personally, I finished chemistry syllabus 1 year before, as I remember, and math syllabus 8 or 9 months before the exam. So for the last year, I didn't have anything to do. I just went for practices. I did music practices, sports practices. I mean, I played in junior national team. I captained my school. I mean, last year was really smooth. I mean, I had nothing to do in A levels in the last year. So I mean, but the initial days, I mean, it's a huge trouble. Okay, I mean, I can't understand anything. I mean, my classes were really fast. Usually, I chose the fastest class in the country, so my classes were really fast. So it's a lot of trouble. But at the end of the day, when in the last year, it was really, I mean, A level was the last thing that I was worried about. Okay, I mean, it was nothing. I mean, I knew that I'm going to get 3 years at the end of the day, so I just don't have to worried about that. So that's how it works. Okay, so the more difficult it is at the beginning, the less difficult it is going to be at the end. If it is really easy, really smooth, and if you are really happy in your A-level class at the beginning, okay, if you feel everything is smooth, okay, everything is going smooth, you understand everything, the questions are really easy, okay, that means you think that you are there. If you feel that, then it is when it's really close to the exam to the A level, then the real trouble will start. Okay, that's how A level classes work. Okay, so yes, that's why I'm starting papers this soon. Okay, then I can make sure that you are having the same schedule as me. Same schedule as me. That means finishing the syllabus early, doing papers every week. If we do papers, I can't do the calculation. We will, I mean, more than 200 300 papers will be done by A levels, right? When we are when we are writing A levels, we will finish like 200 300 papers. Then when you are really really used to papers, writing papers, A level, I mean, doesn't bring any stress to you guys. Okay, why? You every day you write a paper, so it's just another paper. So you go there and write another paper and come home. You don't feel anything about A levels. Okay, when you don't feel anything, any stress, any difficulty, or any I mean, if you are really used to that, if writing a paper is like having breakfast, if it looks like something that you do every day, then that stress related to A levels. If you have maybe sisters and brothers, one of the main problems related to A levels is the stress that you have to go through when you're writing the A level paper. Why you are getting ready for the paper for 2.5 years, then all of a sudden you have to write everything within 3 hours. Okay. So, but that stress, I mean, you won't find any stress like that. I mean, if you write papers every day, right? So, from our side, what we should do is, I mean, we should make sure that writing a paper is very normal thing, okay? Something real. I mean, it's just like having breakfast, okay? It's nothing new, okay? So we have to make sure that. So that's why you are going through a lot of trouble at the beginning in my class, and also we are buying all the practical instruments too. So you will have some practical seminars. That means I'll group you guys into different teams, and I'll ask you to do the practicals. I'll ask you to do the practicals, and I'll let you fill a lab sheet. Okay, that way we can make sure that everyone's going through the proper practical setup. Because I mean, we always take recommendations from teachers. So this time also I talked with different school teachers. That's what they recommend. I mean, now Monarchy, what like whatever they ask, students don't come to the lab and do the practical properly. So if possible, try to make sure that they are doing the practical at least at the class. That was one recommendation done by many school teachers. So these days I have ordered all the practical instruments. So you are going to do the practicals at the class. And for online students, yes, let's make sure like if for the for if I mean, I know there are students from Jaffna, Kandy, Radhapura, Goal, everywhere. If possible, if you can arrange a day and come to Colombo, we can let you do practicals here. Or else, anyways, I'll give you a very nice overview about how to do a practical. I'm planning to buy Meta. Have you seen that? Uh, Ray-Ban Meta glasses that you can capture everything whatever you're doing. So I'm planning to buy something like that to do the practical so that you guys will get the hands-on experience. I have already ordered one. So so I think I'm not sure about that. I'm not sure about that. I mean I'm just buying it for fun, okay? Not to exactly do practicals, but I think we can make sure. I think we will be able to do some nice practical videos using the glasses, using the Ray-Ban Meta glasses. And I mean it's I mean I can use my prescribed glasses there. I can remove the glasses and put those glasses there because they are just projecting things into the glass. So I can use it instead of my glass. Okay. So yep. So everything. I mean the paper plan which we are writing the paper 1 hour before the class. Then we mark you all the papers and everything. The whole plan is for both physical and online class students. Okay. I'll let you know about everything. And at the end of the class, I mean, now you get the paper, marked paper. Within the class, 3 hours of the class, we will mark the paper and let you have it. Then whatever the questions you have related to that paper, okay? Whatever the questions you have, you can directly ask from our invigilating panel after the class, okay? So after the class, I mean, it doesn't matter. Anyways, we are here after class ends at 6:30. We are usually here until 10:30, 11 p.m. Because I mean, we don't have stuff to do at home. So anyways, we can stay here. So if you have any questions, maybe doing some sessions, okay, asking the questions you have related to your paper, you can clarify everything within the day. Okay, you can clarify everything within the day. Then you are done for the day. Okay, then you can happy because you wrote a paper, you learned theory, you asked all the questions, then it's done. Okay, it's done. So I like to finish things properly. Okay, it's nice to finish things properly. Okay, පොඩ්ඩක් කරනවා, then it's not like that. Okay, so let's go with that plan. So your papers will start from next week. So you can come around, class is starting at 3. You can be here around, I think, 2 or 1:30. We'll let you write the paper. 2 time slots, 1:30 to 2:30 for the people who need a half an hour rest. 4 or 2 to 3. For the people who can't write the paper at that time, I'll inform, just let me know. Then I'll let you write in some other time slots. But definitely if you're writing in another time slot, we won't be able to give the paper the same day, okay? That's the only issue. If you're writing the paper before the class, I'll make sure that the papers are marked and you get your marks at the end of the class, okay? That's the plan. Okay. And I like, I mean, every day we'll be publishing the top 10 marks of the class. Okay, and I like people fighting for that. Okay, I like if people fight for that. Why? If anything is gamified, if anything, when something looks like a game, then people prefer to do that. Okay, so I like people struggling to reach the top of the class. Okay, the top of this side tries to be the top of this side, the top of this side tries to be the top of this side. That process of competition, people working together, this process, we like that process. And again, you will be divided most probably based on schools among invigilators. So they will be looking into you personally, and they will most probably, when we are doing practicals, we will ask you to come as groups and do the practicals and finish your lab sheets. Okay, most probably you will be divided based on the school so that it's convenient for everyone. I'll let you know. Okay. So paper plan, we are starting from next week. And online students, check the WhatsApp group around 1:30. Paper will be available in the group. And anyways, from next week, I think we have to do the class from the institute website. I'll put a video about the website. You can get the paper and everything from the website and submit it to the website. Then we will send you the paper, marked paper through WhatsApp or email, okay, by the end of the class. Okay, those are the messages related to today's class. So let's start. Let's start. We are starting. I hope everyone got their tutes, right? Units and dimensions tute. Okay. So today we are starting units and dimensions. And by the first week of May, you will get your tutes. Okay, online students will get their tutes delivered. All the tutes for the month of April and May will be delivered to you guys by the first week of May. There will be a Google form available in the group to get your address. Okay, that is the plan. Okay, so attention. Why do we need this concept of units and dimensions? Why do we need units and dimensions? What is the reason behind this? Let's put a recording also. Why do we need units and dimensions? To make sure that everything is, there's a convention behind everything, okay? Otherwise, one country is selling using pounds and the other country is selling using kilograms. How are you going to communicate? How are you going to communicate? So this reason behind units and dimensions, I mean, the reason to use units and dimension is to standardize everything, okay? That is the basic idea. So I think, there's a video that you should see. Give me a second. I'll try to find the video that you should see. It's better to start with the video.
$200 million orbiter
Online
into
students,
the
can you hear
surface
the
of
sound of
Mars
the video clearly?
actually have to do
Online
with the
students, can
time
you hear it
NASA
clearly?
accidentally crashed a
Sound of the video
$200
clearly?
million orbiter into the surface of Mars. Actually, everything. That crash happened due to an error in converting between two measurement systems, US customary units and their SI or metric equivalents. what does the French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars? Actually, everything. That crash happened due to an error in converting between two measurement systems, US customary units and their SI or metric equivalents. So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place. And different regions didn't just use varying measurements, they had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came. The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole. And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new republican calendar with 10-day weeks reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for formal use, and it spread across the continent along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer. Some European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official. However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully embraced the metric system. Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity. Nevertheless, the metric system is almost universally used in science and medicine, and it continues to evolve according to its original principles. For a long time, standard units were actually defined by carefully maintained physical prototypes. But thanks to improving technology and precision, these objects with limited access and unreliable longevity are now being replaced with standards based on universal constants, like the speed of light. Consistent measurements are such an integral part of our daily lives that it's hard to appreciate what a major accomplishment for humanity they've been. And just as it arose from a political revolution, the metric system remains crucial for the scientific revolutions to come.
Okay, so online students, hope online students now can hear me clearly. So that's the whole story about this SI unit system, okay? So, I mean, I just don't like to teach about the history. I mean, they never asked, so that's why I used a video. So anyways, this is the whole story. It's all about standardization, okay? Just about standardization. Why it's now, we all know now we are in a uh, time which all the transactions are international, right? When all the transactions are international, you can't, I mean, you can't rely on maybe you can't rely on limited units. You need a convention throughout the globe, okay? That's why we use this SI unit system, okay? That was the reason to build this SI unit system. So previously, so it all started with French Revolution, and as they mentioned that 200 million or 300 million crash was really a issue, okay, related to SI unit. As we all know, still US believes in maybe pounds. They are on unit system, okay, for a certain extent. So this was done, as I remember, it was done US and Soviet Union together. So the satellite is using SI unit system, and the station who send the data, they send using pounds and all. So the unit conversion difference, okay, unit conversion difference, due to that, it crashed into, as I remember, Mars. The name was Mars Climate Orbiter. Mars Climate Orbiter, a huge project which was destroyed due to unit conversion issues, okay. That's then the Americans realized that anyways they had to use SI units. So that is the story. And then previously these SI units were defined in a way like this. I mean, they were defined like using maybe this is the equator, using this length from North Pole to equator, then divided by something. This is meter. But we had some issues with this kind of stuff. Why? This is changing, okay? This is changing. The radius of the earth, these things are usually changing at least a bit. Okay, and for kilogram, things like kilogram, we had, I can't remember the country, we have SI standardization building. They had, this is 1 kilogram. They had something, a reference weight. Okay, this is 1 kilogram. But what is the problem? They had 1 meter length, okay, a rod with a length of 1 meter, a cube with a mass of 1 kilogram. They had that in their building, and that was the reference. But what is the problem? I mean, if someone steals this kilogram, then we don't have a reference to kilogram, okay? If someone steals the meter, the rod with the length of meter, then we don't have the meter anymore, okay? So to solve that issue, now everything is defined using like much precise natural conventions. Natural conventions means no matter what is the country, what is the planet, speed of light is constant, right? Okay, no matter what is the country, what is the planet, speed of light is constant. Now we define the meter using speed of light. Take the speed of light, you divide it by something. Then this is meter. Now we define these SI units using these natural conventions, things that which not change based on the planet, based on the province, based on the country. Okay. So now everything is defined like that, and you have to understand that these conventions usually change time to time a bit. So just don't try to study these things. Okay. What is a meter? You have the definition in your note. Okay. Don't even read that part. Okay. Nobody cares what is a meter. Okay. Until you can take a measurement using the meter ruler, nobody cares what is a meter. Okay. Just don't even try to read that part. It's there because, I mean, otherwise there will be complaints that we are not going according to the teacher's guide. Otherwise, nobody cares what is a meter. So if you like, you have spare time, read that part. Otherwise, nobody cares. Okay. Okay. So you have definitions behind all the SI units, but you can forget that. Okay. So today is the, I mean, boring part of physics. And anyways, today we are starting this units and dimensions lesson and measuring instruments. But every day, let's do like 1 or 2 mechanics questions. Okay, to make sure that you know that this is not physics, okay? This accounts, units and dimension and measuring instruments will account for like around 2% of your marks in A levels, okay? Not even 2%, sometimes 1%, 2%. Yeah, 2% of your marks in A levels, you will need units and dimensions and measuring instruments. For mechanics, it's like 25% of your final marks, okay? Mechanics, you need, I mean, around 25% of your final marks in A levels it belongs to mechanics, okay? So we have to make sure that you don't forget mechanics until I start mechanics. That's why from the day one, I work with difficult maths questions, difficult mechanics questions, so that I can make sure that you know what is A levels, okay? Otherwise, when you start with units and dimensions, you think that A levels is converting kilograms to grams, then you think it's too easy. Then it's a chain reaction. Okay, so this is not A levels. This is just something required for A levels. Knowing units and dimensions is a requirement for A levels. That's the reason that we are doing this lesson. Okay. So, and online students, if you have any issues, just let us know. Okay, just let us know as soon as possible. Mali, check the mobile phone, check your phone and the Zoom chat. Okay, if you have any issues, just let us know as soon as possible. I think you have the number. Okay. So, for now, you don't need the tute. Just listen. So this is the idea behind units and dimensions. So talking about this SI system, first of all, we have to understand what is a physical quantity. This whole SI system is there because we need to measure physical quantities. Clear? The whole SI system exists because we need to measure physical quantities. What is a physical quantity? What is a physical quantity? Physical quantity is something that can be measured directly or indirectly. Clear? Physical quantity is anything which can be measured directly or indirectly. Clear? When we are talking about physical quantities, we divide these physical quantities into three types. First type is basic physical quantities or fundamental physical quantities. Basic physical quantities or fundamental physical quantities. What are fundamental physical quantities? Fundamental physical quantities mean something like this. Uh, you take mass, okay, mass, or you take length. Can you multiply length by something and get mass? Or can you multiply time and length and take mass? No, right? Length is very fundamental, right? You can't multiply stuff and get length, right? Length is a direct measurement. Mass is a direct measurement. Time is a direct measurement. But area is not a direct measurement. You measure length, again length, then you multiply. Then you multiply. Clear? So these fundamental physical quantities are the physical quantities which you can derive using other things. They are basic physical quantities. These are direct readings. Okay. Length is a direct reading. Okay. You can't measure the time and mass and divide mass by time or do something like that and take the length. No, you have to directly measure the length. Clear? So these direct measurements are the basic physical quantities or fundamental physical quantities. Clear? Clear? Okay. Then when you talk about a physical quantity, okay, I'll come to that part later. So there are like 1, 2, 3, 4, 5, 6, 7. See, I can't even remember the number, okay? I mean, this is not lesson. So there are 7 basic physical quantities or fundamental physical quantities, okay? One is length, measured in what? Length measured in meters, mass measured in kilograms. Then we have time measured in seconds, time measured in seconds, electric current measured in amperes, thermodynamic temperature measured in kelvins, amount of substance measured in moles, luminous intensity means the light coming out of this bulb, the intensity of light measured using candela. Okay. So these are the basic physical quantities. Okay. These are the basic physical quantities that we have to know. And I mean, just don't try to study these things, but for the first term test, sometimes you need these things. So the best idea is just never study things. I mean, you read this 10 times, you won't remember it. Okay. So just try to understand it properly. Okay. Okay. What are the basic physical quantities? Length, mass, time, things that come to your mind directly, right? Then electric current, thermodynamic temperature is also direct. Then try to remember other three, okay? Or else take a piece of paper. This is what I did for the whole syllabus. I mean, for chemistry, maths, everything. When I can't remember something, I mean, I had a lot of whiteboards in my room. So I write it in a whiteboard. Then whenever I pass through that point, I read it, okay? That's all. Then I read it for like 4 or 5 times randomly per day. when your brain thinks, when your brain sees something repeating again and again, the brain thinks that it is important. Brain assumes that it is important. So it decides that it should be in long-term memory, not in the short-term memory. When you take the book and read it 10 times, brain thinks, okay, this is important, but only for now. So it would go into the short-term memory. Okay, then you are okay at that moment. Then after 1 week, you can't remember anything. But when it is repeating time to time, when it repeating time to time, brain thinks, okay, this should be stored in the long-term memory. Okay, just know how the brain works. Okay, otherwise, I mean, these things should be taught in like grade 7, 8, when how the brain works, how things are stored in the memory. Then, I mean, you don't have to go through the trouble of studying. Okay, okay, I'll try to teach everything related to studying in the class. Okay, I don't like people studying. Okay, it's just a waste of time. Use effective methods to study. Okay, so just take a whiteboard. Okay, write these 7. Then whenever you pass that point, read it one time. Okay, when it repeats randomly, brain knows that it is important. Like that's how you remember the or path to your home. That's how you remember maybe your birthday. That's how you remember your mobile phone number. That's how you remember going to remember your NIC number, which is really long, but now even I can remember it. Okay, so so that's how we remember the stuff. Okay, when things occur randomly, brain knows that it is important, so it anyway stores that idea. Okay, that's how the brain works. Okay, so length, mass, time, electric current, thermodynamic temperature, amount of substance, luminescence density. These are the basic physical quantities. Clear? These are the basic physical quantities. Then what's next? What's next? Then we have derived physical quantities. Okay, we have derived physical quantities. What are derived physical quantities? Area, area, area. What is area? You multiply meters by meters, right? You multiply length by another length, then you get meter squared. Area is measured in meter squared. Clear? Area is measured in meter squared. Then volume, volume. These are derived physical quantities. Another type of physical quantities. Derived physical quantities means something derived using basic physical quantities. Clear? Something derived using basic physical quantities. Then we have volume, volume. Volume means meters into meters, meter cube, meter cube. Tell me the density, density. What is density? Mass over volume, right? Density, mass over volume. What is mass? Kilograms. Volume, meter cube. Then what is the unit for density? Kilogram per meter cube. Okay, kilogram per meter cube. Clear? Then what else? Okay, try to find the unit of force quickly. Unit of force using basic physical quantities quickly. Okay, you can have maybe a piece of paper or something to do rough work, and or just I ruin your book. Okay, anyways, you are going to get everything. Okay, we usually don't write notes. Everything will be included in your notes. Okay, everything will be printed. We are not going to waste time writing notes. So you can just take your book and write when I ask something. Quickly prove. First of all, what is the Newton's law related to? What is the Newton's law related to force? F equals ma. Newton's which law? Second law. What is Newton's first law? Nice, I can hear clearly. What is Newton's first law? When a system is not disturbed, when a system is not disturbed, it remains its motion, right? It remains in its motion. When a system is not disturbed, when there is no external unbalanced force applied on the system, system moves in a constant velocity or system stays stationary. Clear? That is the idea. So, and did I explain you the proof of Newton's first law, right? Yes, right? Newton's first law? Yes? No. Newton's first law, how do we prove Newton's first law? Anyone? No, I didn't do that one. No. Okay, let's learn that. Let's forget units and dimensions. How do we prove this is a time, okay, attention everyone. Attention. This is a time where maths didn't exist properly, okay? When Newton tries to prove stuff, maths didn't exist properly, okay? What is, I mean, maths people know differentiation, integration, these are the things that we usually use in maths to prove anything, differentiation and integration. Even these things were invented by Newton, okay? I mean, he saw something related to physics, so he didn't have enough maths to prove these things, so he invented math stuff. Then using his own math stuff, he proved his physics. Uh, little bit ironical, right? I mean, you invent the maths which proves your physics. So, anyways, so this is a time where, and he did everything before age of 25 or 26. Okay, now we are really close to 26, right? 18, 17, something around that, right? What is your age? 17. Ah, okay, you have time. Okay, so attention, attention, everyone. So the proof is really nice. We call that Galileo's experiment. Galileo's experiment. Uh, you place something, a ball here, a sphere, and this is smooth. What happens? When you release it, it goes like this and returns to the same height, right? Usually it should return to the same height, right? Why? It has a certain potential energy here. If the energy is not lost, it would go and reach here, right? Experimentally, it happens. If this is really smooth, if this path, when you release a sphere here, a small ball here, it goes and return to the same height. Clear? It returns to the same height. Okay? Then what they did was they just increased the angle here, changed the angle here. Then again it returned to the same height. Again it returned to the same height. Clear? Clear? Then again they increased the angle. Still it returned to the same height. Still it returned to the same height. Clear? Whatever the angle here, it returned to the same height. Then what they did was they made the system like this. This is the hypothesis here. It always returns to the same height. In this scenario also, it should return to the same height. But since it is flat, it will never return to the same height, so it will move forever. So it will move forever. That was the hypothesis. Okay, when the maths didn't exist, that's how they proved stuff. Okay, see how nice. I mean, it returns to the same height. Whatever happens, it returns to the same height. You keep increasing the angle or decreasing the angle, it returns to the same height. So even in this situation, it should return to the same height. But since it's horizontal, it can never return to the same height. So it will move forever until it return to the same height. That means when the system is not disturbed, it will be moving forever. Clear? It's going to move forever. Okay. Why do we need to learn these things? Yes, Galileo's experiment is not in the syllabus. Okay, but you may get questions. Okay, why? When I mean, the physics is for thinkers, okay? So when they give a question like this and ask what is the theorem that we are going to prove here, then one day, not now, you should be able to understand, okay, this is Newton's first law. Okay, I mean, thousands, hundreds of years ago, if Newton understood this one, why can't? I mean, now you have mobile phones and all, you should be, I mean, you must have a higher IQ than him. So, I mean, we must be able to, one day we must be able to understand, okay, this is Newton's first law. Okay, why? That's how they give the questions, okay, not this difficult, okay. That's how they give the questions. They always give a practical scenario, okay. They always give a practical scenario and you have to go through that practical scenario and understand which physics concepts to apply here, okay. That's why from day one, whenever possible, I try to apply physics concepts, okay. That's why we always try to apply the physics concepts. Okay, so just make sure that, that's why I always ask you whether you have watched this movie, whether you have watched that movie. Okay, and I mean, I can remember the same type of question was there. I mean, attention everyone. You seen in all the movies, spaceships are rotating in many sci-fi movies. Why? To create artificial gravity. There was a question once in A-levels, and the people who have watched the movies properly, they know that the ships rotate to create the artificial gravity. That's why I always ask whether you have watched this sci-fi movie, whether you have watched this movie, whether you have watched this video. The idea about this practical nature of physics, not the theorems, okay? this practical nature of physics, this kind of a concept can be applied here, this kind of a concept can be applied here. When you have seen a lot of practical applications, then you can link whatever the question they give with the theories you know, okay? Okay, that's why I always ask you to watch, yes, watch the sci-fi movies, okay? Watch some videos related to physics, okay? You must have that practical knowledge, first of all, okay? We can slowly build these things, okay? I mean, every day I'll be showing you some kind of practical scenarios. It's not because it's required for units and dimensions. It's because at the end of the day, questions, they don't give you F and M as the acceleration. They give a practical scenario. There's a spaceship going like this, and there's a collision. Then after that, what happens? So they always link our questions with practical scenarios. So we must have the capacity to understand practical scenarios using the physics concepts that we know, okay? That is the basic idea. Clear? Ah. So, okay, back to units and dimensions. So, F equals, how can we derive the units of this one? F equals, using F equals MA. What is the unit of mass? Kilograms. Kilograms. Acceleration? Meters per second square. Kilogram meters per second square. So this is the unit. This is the unit for force. Clear? Derived physical quantity. But it has a certain name given to this. Instead of this, what do we use to write force? Newtons. We write force in newtons, right? So they are in SI system. Okay. In SI system, we give shortened forms or names for derived physical quantities also. Something like this. Force, the actual SI unit is kilogram meter per second square. Clear? But you have a common, combined name for this combined unit called newtons. Why? Usually to make things easy, okay, to make communication easy. Otherwise, if we always have to mention this, it's a trouble. And again, to usually to respect the people who have invented this stuff, okay? So you have derived physical quantities with special names. You have a whole table with these units. Force measured in newtons, pressure measured in pascals, energy measured in joules, power measured in watt, frequency measured in hertz, electrical charge measured in coulombs. Okay, I mean, just read these tables. So, I mean, you know this one, right? Pressure is measured in pascals. So, what is the actual unit of pressure? Quickly find the actual unit of pressure. Quickly try to get the actual unit of pressure. Actual unit of pressure. Actual SI unit of pressure. Let me know, or else send a cheat when it is too cold, okay? As I mentioned last week, the ACs are always in 19 in my classes, okay? So whenever required, let me know, I'll increase the temperature. I mean, it's at 19 because it can't go to 16. I don't know why. So just send a cheat or just let me know when it is too cold, okay? Okay, so here we have F equals ma kilogram meter per second squared. Clear? So pressure. What is the definition of pressure? What is the definition of pressure? Force. Nice. Force over area. Force over area. So force measured in. Now we have this one, right? Force measured in this one. Area measured in meter squared. Then what do you get? Kilogram per meter per second squared. Clear? Kilogram per meter per second squared. Okay. So I mean, just don't try to study these things. Okay. Power. But what is the common name given to this one? What is the common name given to this one? Pascals. Pascals. So to respect this person, okay? That's how it happens. So watts, Coulomb, Volt, Tesla, Weber, Pascal, Joule, all these are people, okay? Not units actually, they are people, okay? So, I mean, just don't try to study these things. Why? You will electrical charges measured in coulombs. Just don't try to study. There's a separate lesson called current electricity. There you will write this unit for maybe 1,000 times. Okay, then you will eventually remember it. Okay, so just don't go through the trouble of studying these things. Okay, attention everyone. Just don't go through the trouble of studying these things. We have lesson for every unit. Okay, hertz we discuss it in waves and oscillations. Charge we discuss it in current electricity. Electromotive force we discuss in electromagnetics. Electrical resistance we discuss in current electricity. So you have lessons for all these units. So in each lesson you will understand. Then you don't have to study. Okay, just don't try to study. Just know that these kind of stuff exist. Okay, that's all. Okay, so next one. There are some physical quantities without units also. Some derived physical quantities. There are some derived physical quantities without units. Relative density, did you have it in O levels? No, right? Relative density. Okay, what is relative density? It's a unit. Oh, it's a physical quantity. Relative density means rho r. Relative density means density of something over density of water. There are physical quantities like this. Okay, there are physical quantities like this. We call it relative density. Density of something over density of water. When you divide these two, units will cancel out, right? Here you have the units of density. Here you have the units of density. Then they will eventually cancel out, right? Clear? Clear? Relative density is a physical quantity, but it doesn't have a unit. Clear? There are physical quantities like that: relative humidity, relative permittivity, coefficient of friction, refractive index, efficiency, strain. Okay, and again, just don't try to study. For strain, you have properties of matter lesson. For efficiency, you have work power energy lesson. Refractive index, you have optics lesson. Coefficient of friction, you have Newton's laws lesson. For relative permittivity, you have static electricity lesson. There's a lot of lessons. Okay. So just don't worry. Just don't go through the trouble of studying these things. You will find these things eventually in different lessons. Okay. Just know that these kind of things exist. Okay. Okay. Attention. Next one. Another type of physical quantities. Okay. Now we have learned two types of physical quantities: fundamental physical quantities, derived physical quantities. Derived physical quantities. Clear? The next type is supplementary physical quantities. Supplementary physical quantities are the physical quantities which doesn't fall into any of these categories. Okay. Supplementary physical quantities are the physical quantities which does not fall into derived physical quantities or fundamental physical quantities. The examples are angle in plane, that means we measure it in radians, and solid angle. What is this angle? How do we measure angle in O-level syllabus? What is the unit? Degrees, right? Degrees. But actually the proper SI unit, okay, proper SI unit to measure angle is not degrees, it's radians. It's radians. I'll teach you radians now. I mean, we don't exactly need to teach radians now, but I think it's convenient for you to teach it because otherwise I had to ask you to believe that something called radian exists. It's easy to teach it rather than asking you to believe it. So, what is radians? Radians is the original SI unit of measuring an angle, okay? Original SI unit of an angle, clear? Original SI unit of an angle. So, assume that I need to find this angle theta. I need to find this angle theta. Maybe it may be 30 degrees, 15 degrees, 25 degrees, something like this. But when we try to measure it in radians, this is how we measure an angle using radians. This length is S. This length is S. If the radius of this circle is R, theta in radians is taken by S over R. It's measured by S over R. Clear? Theta radians is measured using S over R. This length over R, this is theta radians. Theta radians. So if we ask you to measure something using radians, this is how you're going to get it. Clear? Okay. S over R. Clear? So if you need to measure this alpha angle, if this radius is 5 meters, if this length is 2 meters, alpha equals what? 2 over 5. 2 over 5 radians. Clear? 2 over 5 radians. Clear? So try to create a relationship, okay? Try to create a relationship between radians and degrees. Try to create a relationship between radians and degrees. Quickly try to derive a relationship. And I mean deriving a relationship, these kind of stuff usually I should teach, okay? This kind of stuff usually I should teach, but always I ask you to try to derive it. Why? It's good for your brain, okay? That's why. So if you can't get the answers, just don't worry. But I like if you can try, okay? That's all. I like if you can try. So I'll help. You know, attention everyone, you know, what is the angle in full circle? 360. Use that. And I mean, if you don't like this process, I mean, me asking you to prove everything, I mean that's how I used to learn physics. Okay, I said it in first week. Like my physics teacher was Mihira Jivananda, like a very nice engineer in Sri Lanka. So even first day in his class there is like 30 students, and in the second day it's only around 6 students. Okay, so the reason is, I mean, he always asks us to prove stuff, okay? He always asks us to prove stuff, so nobody likes that. But at the end of the day, today I'm here due to that reason. Why? Whenever I ask something, he just give me the guidelines and ask me to try to prove that. That's all. So I just try to prove it for 2-3 weeks, okay? I get nothing. But in the process, I just learn to think. I just learn to think. So that is the only reason that that is the only reason for me being good at engineering, me being good at teaching, me understanding physics, me understanding Olympiad physics, everything due to that teaching method, okay? So I just need everyone in my class to be like that. That's why I just ask you to prove stuff. Okay. So let's consider a full circle. This full angle, this full angle, this full angle in degrees, it's 360 degrees, right? Equals, how to write this full angle in radians? You just take this whole distance s and it divide by r, right? Whatever the, what is the definition of radians? If you need this theta, you take s over r, clear? So if you need the full circle, s means full circle, right? S means full circle divided by r, right? That's how you get it in radians, clear? So what is full circle? 2 pi r, clear? Full circle is 2 pi r. Full circle is 2 pi r. Length of the full circle is 2 pi r. You divide it by the radius r. This is the answer in radians. So this is the same angle measured in degrees and measured in radians. Clear? This is the same angle measured in degrees and radians. Is that clear? Clear? So r to r cancels out. You have 360 degrees equal 2 pi radians. 2 pi radians. If you divide it by 2, 180 degrees equals pi radians. Clear? 180 degrees equals pi radians. Clear? Okay. So this is the idea. So just tell me 30 degrees in radians quickly. 30 degrees in radians quickly, right? 30 degrees in radians. Pi over 6. How? How are you going to get that? I mean, just use something like this. If it is pi radians for 180 degrees, how much for 30? Okay, if you get 10 mangoes for 50 rupees, how much for 10 rupees? Okay. If it is pi radians for 180 degrees, how much for 30 degrees? Clear? Clear? Using this, I mean, why? Usually we are used to take everything using degrees, okay? But syllabus is more based on radians. So in syllabus, we have to always convert between radians and degrees. Okay. I will teach this again. I have to learn this in rotational motion and everything. But this is the relationship. Okay. So if you know that it's 5 radians for 180 degrees, how much for 30 degrees? Clear? Clear? Then you get pi over 6. So 30 degrees means pi over 6 radians. Clear? 30 degrees means pi over 6 radians. Clear, everyone? Clear? That's how you're going to get angles, measure angles. Clear? So there's another thing. So this is measured in radians. This is the definition of radians. Okay. Then you have steradians. Okay. Then you have steradians. We usually don't we are not going to get questions. Attention, everyone. We are not going to get questions from steradians. Okay. It's just introducing. We are just going to introduce it here. Then after that, we are not going to use it again. Okay. Radians, yes, we always use. Steradian is a 3D angle. Okay. Steradian means a 3D angle. That means this is two-dimensional angle, right? This is an angle in this plane, right? This is an angle in this plane, right? But so steradian means, okay, steradian means something like this. You have a sphere, attention everyone. You have a sphere, you draw a square or any shape with 1 meter squared. Assume that the radius of this sphere is 1 meter. You draw on the surface of this sphere, you draw an area equal to 1 meter squared. Clear? An area equal to 1 meter squared. Then it creates an angle here, right? That area creates an angle here, right? Something similar to a cone. Okay. It creates an angle like this here. If you use an area on the surface, okay, if you use an area on the surface, you are going to get something like this, right? An angle like a cone here. Clear? That's what we call a 3D angle. Okay, a 3D angle. Okay, it's measured in steradians. Okay, it's measured in steradians. If this area is 1 meter squared, if this radius is 1 meter, then this angle is 1 steradian. Clear? This 3D angle you get here, it's 1 steradians. Clear? So we are going to learn this 3D angle, or we call it solid angle here. Then after that, we are not going to learn about this thing. Okay, that's all. Clear? Clear, everyone? Clear? So these are supplementary quantities. Okay, these are supplementary physical quantities. That means they do not, I mean, there's a reason behind this. Usually radians means, see, length divided, attention, usually radians means length divided by length, right? Radians means length divided by length, right? I mean, when you divide length by length, usually it should not have a unit, right? Length divided by length means meters to meters cancels out. Length divided by radius, that means meters to meters cancels out. So it should not have a unit, right? But it has a unit called radians, okay? So it does not fall into any category, right? It does not fall into any category. It's not a fundamental physical quantity. It's not a derived physical quantity. Why? If it is a derived physical quantity, it should not have a unit, right? It can't have a unit. Why? If it is a derived physical quantity, SOR, meters to meters cancels out, then it can't have a unit. Clear? But it has a unit. Okay. So this solid angle and plane angle, we call them supplementary physical quantities because they don't fall into fundamental physical quantities or derived physical quantities. Clear? Clear? Okay, and there's another definition related to supplementary physical quantities, which is related to dimensions. Later I'll teach that part when we are done with dimensions part. So is this clear, everyone? Is this clear? Okay. And the next part, when we are working with units, now we know the types of physical quantities. We know a set of units. Okay, we know a set of units. And when we know all these things, okay, next step is writing different physical quantities using units. Attention, in that process, okay, in that process, sometimes some units are too large, some units are too small, right? Okay, I mean, if you have to measure I mean, the distance between countries, if you measure it in meters, it's not convenient, right? It's better to measure it in kilometers, right? Like that, in certain scenarios, some units are too small and some units are too large. Clear? To solve that issue, we have multiples and submultiples. You know, right? Multiples and submultiples. That means when a unit is too large, we use submultiples. Things like centimeters, millimeters, centimeters, millimeters, micrometers, nanometers. What is centimeters? Means 10 to the power minus 2 meters. This is a smaller unit than meters. Clear? What is millimeters? 10 to the power minus 3 meters. Micrometers, 10 to the power minus 6 meters. 10 to the power minus 9 meters. Then it continues like that. Nano, pico, femto, atto. It continues like that. Clear? Okay, when I mean to measure the length of this one, since 1 meter is too large, we use centimeters. Clear? That's the use of submultiples. Clear? That's the use of submultiples. Clear? Then sometimes to measure rods, meters is not enough. You have to use multiples. What are the multiples? Kilometers we have. What? Then we can use maybe megameters, gigameters, okay, gigameters, terameters, okay. These are capital, okay. Usually these are capital. These are simple. Submultiples are usually simple. Multiples are capital. What is kilometers? What is kilometers? 10 to the power 3 meters. What are megameters? 10 to the power 6 meters. Gigameters? 10 to the power 9 meters. Tera? 10 to the power 12 meters. Clear? It's like that. Clear? It's like that. 10 to the power 3 meters, 10 to the power 6 meters, 10 to the power 9 meters, 10 to the power 12 meters. Clear? It goes like that. So then after that you have tera, peta, exa, 10 to the power 12, 15, 18. Okay. So we use these multiples and submultiples to convert, units to a convenient size. Clear? So this is the idea behind multiples and submultiples, and we must be able to convert things properly. Okay. Just let's try some questions. Exercise 1. These are really easy questions, so you can finish them quickly. Try exercise 1, question number 2, 3, and 6. Question number 2, 3, and 6. For the students who don't have the tutes will be available in the Zoom chat again. Tutes will be available in the Zoom chat again. And if you can't find the tute, just put a message to this number. Provide your number. And if you can't find the tute, or if you need to join the group or anything like that, just contact this number, 070-402-9701. 070-402-9701. Just send a WhatsApp message to this number. And try to convert 36 kilometers per hour to meters per second. Convert next one. After these three questions, try 36 kilometers per hour, convert it to meters per second. Then 18 revolutions per minute. 18 revolutions per minute. Okay. Revolutions means cycles. 18 circles or cycles per minute, convert it into radians per second. Radians per second. Try these things. And we'll give you the, I think everyone got the mechanics tute also, right? So, I mean, just don't waste time, okay? If you're done with the questions, okay? If you're done with the questions, quickly go to the mechanics tute and try to finish the mechanics tute, okay? That's why you always get more tutes than, I mean, it is possible to finish, okay? You're going to get more tutes. Why? Uh, I mean, some students understand stuff quickly. Some students finish questions quickly. So I don't need you to wait. If you're done with the question, quickly take the mechanics tute and try one or two questions. Okay. Question number 2. Question number 2. Diameter of a coin is 25 millimeter. What is the length in meters? Diameter of a coin is 25 millimeters. What is that length in meters? That length in meters is 25 into 10 to the power minus 3 meters. 25 into 10 to the power minus 3 meters. Why? Milli means 10 to the power minus 3, right? Milli means 10 to the power minus 3. So instead of milli, you write 10 to the power minus 3. You can always write, instead of 10 to the power minus 3, you can write milli. Instead of milli, you can write 10 to the power minus 3. That's how it works. Clear? Then a capacitor takes 100 microseconds to charge. What is the time in seconds? Question number 3. 100 microseconds. So instead of micro, you can write 10 to the power minus 6. Instead of micro, you can write 10 to the power minus 6. Instead of microseconds, you can write 10 to the power minus 6 seconds. Clear? That's how it works. Question number 6. 4 kilometers squared. 4 kilometers squared means 4. Attention everyone. 4 kilometers squared means what? Kilo means 10 to the power 3. But here it's squared, right? It's squared. Clear? So that means it's not kilometer squared, it's kilometer squared. That means this 10 to the power 3 should be squared, right? 10 to the power 3. Kilo must be squared, right? Then meter squared. Then meter squared. Clear? Clear? Is that clear, everyone? So you get 4 into 10 to the power 6 meter squared. 4 into 10 to the power 6 meter squared. Clear? Okay. Then what else? These two. Try these two questions. 36 kilometers per hour, convert it into meters per second. 18 revolutions per minute, convert it into radians per second. And online students, make sure that you have joined the group, okay? Join the WhatsApp group. Because like, make sure that you log into our website. I'll provide you an instruction video for online students. Make sure that you log into our website and arrange things properly so that you can join the class using our website. I'll provide it in the group, okay? I'll provide all the details in the group related to joining the website. So you had to log in, you had to put your details and create your login properly, okay? So just make sure that you arrange stuff. Okay, 36 kilometers per hour. Attention. 36 kilometers per hour. So just think naturally, okay? Just don't, you don't need to, okay, instead of kilo, I had to write this. Instead of hours, I had to write this. It's not like that. Just think naturally. 36 instead of kilo, 10 to the power 3. Kilo means 10 to the power 3. If it is per hour, what is per second? You divide it by 3600, right? Why? There's 3600 seconds per hour. If it is this much per hour, how much per second? You divide it by 3600, right? If this is per hour, that means it is for 3600 seconds. Then you need what is happening per second. Clear? So, if this is per hour, to take the quantity per second, you divide it by 3600. Clear? Just think naturally like that, okay, when you are converting units, okay? 36, instead of kilometers, you can write 10 to the power 3. If it is per hour, how much per second? You have to divide it by 3600. Clear? Meters per second. And since these kind of conversions you always get, it's good to simplify these kind of things. Okay, I don't have to tell things like this. It's good to simplify and remember these things, since I mean in all the mechanics questions, always you have to convert kilometers per hour, meters per second, meters per second into kilometers per hour. So it's easy to, attention everyone, it's easy to solve this part. Okay, how? 36, here 1000, 10 to the power 3 means 1000, here 3600. What do you get here? 5 over 18. So it's 36 into 5 over 18. So when you need to convert something into kilometers per hour, I mean, if you need to convert kilometers per hour into meters per second, you always have to multiply by 1000 and divide by 3600. That means multiply by 5 over 18. So these kind of things, it's good to remember. Okay. Then in all the mechanics question, you can apply this directly. Clear? Attention. Okay. In all the mechanics question, you can apply this directly. Clear? So we get 1 and 2, then 10 meters per second, right? 10 meters per second. Clear? And make sure that, attention, and make sure that everything is neat, okay? Everything is neat means, I mean, you have something like this. Okay? So, if you need to solve something like this, only attention, everyone there, attention. So if you need to solve something like this, I mean, you divide this by 6, 2 and 3, you divide this by 4, 1 and 14, right? So, see, I cancel out these two in this direction, these two in this direction. Why? These are not very easy one-step questions, okay? These are not easy one-step questions. In mechanics, we are not going to get easy one-step questions. Sometimes you have to solve for 2-3 pages. So at the end of the day, I think, I mean, in the last page, if you get the answers, you have to find the velocity of a person. You get 120 meters per second. Then you know you have missed something, okay? People can't run with a velocity of 120 meters per second, okay? So in the last page, after doing calculations for 2 pages, you all of a sudden get the answer as 120 meters per second, velocity of a person. Now you know you missed something. Now you have to trace back and check where you missed, okay? When you check these things, now you have to see. Now when here you can see, okay, I have cancelled out 12 with 18. I have cancelled out this with this one. Then I check these two. Okay, this is correct. 2. This is correct. This is 1. Correct. This is 14. See, you can easily check where you have missed. Okay. So if you have instead of 14, if you have written 16, something like this, now you know when you check these two, I have cancelled out 4 and 56. I have solved these two together. This and this I can check. This and this I can check. Because otherwise it's not like this. Okay, you have like 5 difference values on the top, 5 difference values in the bottom. Okay, now it's difficult to figure out where you missed. Okay, so it's always, I mean, make sure that you write everything in a way that you can check. Okay, so if you have 2 other values, maybe 15 and 5, okay, just change the angle a bit. Okay, just change the angle a bit, or just make it horizontal like that. Clear? Just make sure that you know where you I mean, how did you solve these things, okay? And for maths people, your writing must be readable, okay? For maths people, your writing must be readable. It should be, I mean, you should be able to, I mean, we must be able to read these things properly. Why? At the end of the day, the person who's gonna mark your paper, he or she have no idea about you. Okay, when they see the paper, first impression is your handwriting, okay? First impression is your handwriting. And they usually mark maybe 20-30 papers per day, sometimes more than that. So think, I mean, if your handwriting is not readable, okay, think how much of a trouble they have to go through to mark your paper in LL marking, okay? Attention everyone, okay? How much of a trouble you have to go through in, they have to go through in marking. So just make sure that your letters, your writing is readable. And for bio people, I think it should, bio people please raise your hand. Okay. Okay, so for bio people, your writing must be not readable. It should be beautiful, okay? Okay. Why? I mean, maths, we only see few handwriting. 90% of them are numbers. Okay, but for bio people, the person who's going to mark your paper has have to read, I mean, paragraphs, okay? So if you're, I mean, if you're being readable is not enough for you guys, your letters must be, your writing must be at least a little bit beautiful. Why? Then it's pleasant to read, okay? There's a lot to read, so it should be pleasant to read, okay? So that's the basic idea. For maths people, your writing must be readable. For bio people, your writing must be beautiful. So, and I mean, you can't go home and arrange another time for your handwriting. What you can do is in the class, just improve your writing a bit. Then ask your friend whether this is readable, okay? Okay, if you know that if your handwriting is good or not, then in the class, next time when you're writing something, try to improve it a bit. Next time, try to improve it a bit. Then ask your friend again, okay, now is this okay? Clear? Clear? Just repeat it like that, okay? Repeat it again and again like that. Okay, you can't arrange separate time or take that handwriting book and improve your handwriting. You have to do everything in the class, okay? Whenever you are writing, make sure that you are improving your handwriting a bit every day. You are making it faster. You are making it readable every day a bit, at least a little bit. Then by after like 2-3 months, your handwriting will be fast and readable. Clear? Okay. So just use the class time for everything, okay? Then you can go home and do whatever you like. Okay. $18 revolutions per minute. How can I attention? How can I convert into radians per second? Revolutions converting into revolutions. How can I convert revolutions into radians? 2 pi multiplied by 2 pi. This means rounds. How many rounds? What is the amount of radians per one round? Full round. 2 pi radians, right? One full round means 2 pi radians. Can you remember? One full round means 2 pi radians. So 18 revolutions means 18 into 2 pi radians, right? 18 revolutions means 18 into 2 pi radians. Clear? And this is for minute, per minute. How can you get what is happening per second? If something is happening, I mean, if there's this value per minute, per second, to get per second, you have to divide it by 60, right? Okay, I mean, if you can run 100 miles per minute, what is the distance that you can travel in second? You divide the distance you can travel in minute by 60, right? Why? There's 60 seconds per minute. Clear? So just think naturally, okay? So I get 18 revolutions into radians. I multiply by 2. Okay, why? Per one round, per one circle, you have 2 pi radians. Can you remember? Then it's in per minute. I need the value per second. Clear? I need the value per second. So I divide it by 60 and get the value per second. Clear? Clear? That's how we analyze, okay? Just make sure that unit conversion is a very natural thing, okay? Like when you add 2 and 3, you now don't do any kind of a calculation, right? 2 plus 3, you know that it's 5, right? So just make sure that unit conversions are comfortable like that, okay? Next week you will get a workbook, okay? Next week you will get a workbook for units and dimensions and measuring instrument. There you have a lot of questions, simple questions, okay? A lot of questions. You will get a workbook with lot of questions. You can try that, okay? Then I'll discuss 1 or 2 questions per week from the workbook again. So just make sure that, unit conversions is something natural to you, okay? Not something that you have to think or analyze, okay? Just 18, okay, revolutions per minute. I multiply by 2 pi to convert into radians. This is per minute. To take the value per second, I divide by 60. Clear? Just make sure that it's natural like that. Okay. Okay. Uh, Next one. After the interval, let's do some mechanics questions again. But we need the interval now? No, right? No, right? We didn't learn anything new. 452. Can I have a mechanics too? I can just give the numbers to try. Okay, I hope you have seen the video. I discussed first 10 questions. First 10 questions of this tutor. I uploaded the recording to your group. I did it at that Nonagate time. I had nothing to do at that time, so I did that recording and uploaded in the morning. You should have seen that. Okay. Mechanics tute. Mechanics tute. Question number 12. Then in that video, I said that I'll discuss question number 9 in the class. So question number 9. In question number 9, there's a small correction. Attention, everyone. In question number 9, there's a small correction. The question is the speed of A is 54 kilometers per hour, while the speed of B is 36 kilometers per hour. B is the vehicle in front. The question is time taken for A to pass B. That means B is here, B is here, A is here, A is here, B is here, A is here. Time taken for A to pass B. Okay. Now the situation is like this. B vehicle is here, A vehicle is here. Time taken for A to pass B. Question number 12, 9. Then I'm not sure whether I discussed this question or not. But try 23 if you have time. This is difficult, okay? This is difficult. Try question number 12 and 9 first. Then let's move to question number 23 if possible. Then let's continue with units and dimensions again. So for online students, Mechanics Tute will be available in the group again. It will be available in the WhatsApp group, Zoom chat. And for YouTube live students, if you can't find the tute, just send a message to that number. Just put a message to this number, WhatsApp message to this number. And make sure that you are joining the WhatsApp group too. Okay. Time is 4:56. I'll start around, maybe you can come to the class and start trying these questions at 5:15. I'll be starting the discussion around 25 or around 5:25, but you can come to the class around 5:15 and start doing these questions. Try to get answers. I mean, if you can't get the final answer, okay. Anyone who didn't get the mechanics tute? Anyone who didn't get the mechanics tute, raise your hand. You will get the tutes. And online students, if you can't find the tute, just let us know in the Zoom chat or contact this number. Okay, I'll give you like 5 to 10 minutes to try the questions. So if it is difficult to get the final answer, just try to draw at least the diagram. Okay, try to draw the diagram at least. Thank you. And as I mentioned before, question number 9, a small correction. The last part of the question is B is the vehicle in front. Time taken for A to pass B. Time taken for A to pass B. Time taken for A to pass B. Okay, you need the mechanics tute again. We'll upload it again in the Zoom chat. Again, one thing that is really important in mechanics and in physics is drawing a perfect diagram. Okay, so if you can't get the, I mean, you can't get the final answer. If you can't get the final answer, just try to draw a perfect diagram. Okay, just try to draw the perfect diagram for the question. And if you get the answers for these 2 questions, try 23 questions, then just try to finish the tute. Okay, if you're done with all the questions, try to finish the tute. Just don't waste time. That's all. So most probably next week paper will be a MCQ paper. Some units and dimensions questions and few mechanics questions. So you can be here around the class is starting at 3. So you can stay be here by 2, then the paper will be from 2 to 3. If you come at 1:30, paper will be from 1:30 to 2:30. Class is from 3 to 6:30. It's not mandatory. Okay, if you don't like, you can, you can skip that and come to the class directly. Okay, it's not mandatory. Right in the paper, it's not mandatory. Okay, but I think it's really beneficial. Okay, I just need everyone to like perform your best at first term test. Okay, attention everyone. I need everyone to perform, get the best marks possible for first term test. Okay, why the first term test marks make your life easy. Okay, why? Then these attendance problem, sometimes like even you may have to go to practices, all these problems. But you want, usually teachers don't allow you to go to practices. There's a lot of problems in A levels. Why? It's their job to make sure that you're going to get good marks. Okay, so there's a risk. Okay, why? Whenever people go to practices and skip classes, they are going to get low marks. Okay, they have seen that, teachers have seen that. So all your problems can be solved if you get very good marks in first term test. Okay, then you give the guarantee to your teachers that don't worry, whatever the practice I'm doing, although if I miss 1 or 2 days at school, whatever happens, I'm going to get good marks. Okay, if you can give that guarantee to your school, then they are not going to chase you. Okay, so getting very good marks in the first term test is really important. So if we can write a paper every week, term test will be really easy. Okay, term test will be really easy. Why? Then it's something that you do every week. Okay, you will feel the term test like just another day of class. Okay, you just go there, write the paper and come home, you will get very good marks. That's all. Okay, so if you can write this paper, it will make your life really easy. Okay, so paper is here. Physically, paper will be given in the class. Uh, and for online students, there will be online submission form. We will make the paper available. There will be online submission form. You can submit the answers to that online submission form. It will be available in our website and the group, both website and the group. So make sure that you are in the website and the group. Okay. Uh, Details related to the website, how to join the website, everything will be given in the everything will be informed in the WhatsApp group. Question number 12. Question number 12. I'll start with question number 12. There's a sheep. There's a sheep. Its echo is heard after 16 seconds. There's something like a wall here. There's something like a wall here. Attention, everyone. Stop talking. Everyone. Okay. And if you get the answer for this question, if it is easy for you, you just don't have to listen. Just keep doing the questions. Okay. Just keep doing the questions if you get the answer and if the question is easy. Okay. Usually you don't have to listen in my class if you understand it. Okay. So you have enough tunes, enough questions. You can just continue doing questions if you understand this one. But we have to make sure that you remain silent when I'm explaining, because there are people who need to learn this part. Okay. So you are free to, just feel free to not to listen. If you get the answers and if you understand very well, then just continue the question tute. Okay. Just try to finish the tute, but just don't talk. Okay. Okay. So here, question number 12. When a shot is fired from a ship moving at a uniform speed towards a rock on the shore, its echo is heard after 16 seconds. Okay. Sound travels and returns after 16 seconds, right? That's the meaning of echo. Okay, that's the meaning of echo. So it travels like this, then returns, then returns. So if it is 16 seconds, that means it travels 8 seconds in this direction. It travels 8 seconds in this direction and 8 seconds in this direction, right? Clear? If it is altogether 16 seconds, that means it travels 8 seconds in this direction and 8 seconds in this direction, right? So we know what is the definition of velocity. velocity is displacement over time, right? Velocity is displacement over time. Then what is displacement? Velocity into time. Displacement is velocity into time. Clear? So I get, what is the velocity of sound? They have given it as 350. Velocity of sound is 350. Velocity of sound is 350. Time 8 seconds. 8 seconds. Attention everyone. I hear people talking. So time, velocity 350. Velocity 350. Velocity of sound. Time from here to here, it's 8 seconds. That means what is the answer? 1800, right? Okay. So this distance is 2800. This distance is 2800. Then after half a minute, it's here, somewhere here. Then to hear the echo, it takes 12 seconds. Then to hear the echo, it takes 12 seconds. So sound travels in this direction and then this direction. So it travels 6 seconds in this direction, then 6 seconds in this direction. That's why it takes 12 seconds to hear the echo, right? So what is this distance? Again, S equals Vt. S equals velocity of sound 350. Velocity of sound 350. Time taken 6 seconds, right? Time taken to travel from here to here, it's 6 seconds, right? Then what is the distance? 2100. 2100. Clear? So this distance from here to here, the distance from here to here, it's 2100. So it's 2800 and 2100. What is the gap? What is the difference? 2800 minus 2100, it's 700, right? So this gap is 700, right? 2800, here it's 2100, then it is 700. Why? Yes. Yeah, definitely. There's an issue like that. I mean, when the sound travels, at that time the ship is traveling, right? That thing you can forget. Why? The reason is, I mean, it's good. That concern is valid. Why? It's not like ship stays here, then sound goes and returns. It's not like ship stays here, sound goes and returns. When sound goes there, ship is moving. It's a good concern, right? When sound travels, at that time also ship is moving. But then the question becomes a little bit complex. But we can think something like this. The distance traveled by the ship, at that time we can neglect that relative to the distance traveled by the sound. Okay, it's entirely based on that assumption I'm doing the question. Okay, it's a really valid concern. Okay, you understand that concern? I can't just think that sound travels 6 seconds and returns in 6 seconds. Why? When sound is traveling, ship is also moving. Clear? So sound travels a certain distance, then sound travels a smaller distance. It returns a smaller distance. Okay, then the question becomes a little bit. Yeah. Yeah, definitely we are working with the average at this point. Okay, why? What is the reason? Uh, I mean, using that method, I can explain if you like. We have to use relative velocity to do that, right? Why sound travels in this direction, ship travels in this direction. So the question becomes a little bit complex. So I'm doing the question entirely based on one assumption. What? The sound travels really fast. So when the sound is traveling, within that time, the distance traveled by the ship, I'm going to forget. Okay, for now. Okay. In mechanics, when we learn relative velocity, I mean, we already know relative velocity, but not to a proper extent. Okay. Last week we did one question from relative velocity, but it's not the entire idea of relative velocity. Okay. So since we don't have a very good idea in relative velocity, I'm doing the question based on that assumption. Okay. What? Ship stays here, sound goes and returns really fast so that I can forget the distance traveled in that time. Clear? So again, when he's here, sound travels in this direction and this direction. It travels in this direction for 8 seconds and in this direction for 8 seconds. Then ship comes here, sound travels in this direction for 6 seconds and it returns in this direction for 6 seconds. Clear? Then this distance is 2800, this distance is 2100, then this is 700. Clear? The gap is 700. Ship took half a minute. Half a minute means 30 seconds. Ship took 30 seconds to travel this distance. Clear? This ship took 30 seconds to travel this distance. Clear? Then what is the velocity of the ship? Distance over time. Distance over time. What is the distance? 700. Distance of the ship is 700. Time taken 30 seconds. Clear? Time taken for the process is 30 seconds. So answer is 70 over 3 meters per second. Clear? Answer is 70 over 3 meters per second, but based on that assumption. Okay? Entirely based on that assumption, that concern is entirely correct. Okay? We still haven't done enough mechanics to analyze it easily. That's why I neglected that part. Question number 12. Try question number 12. Sorry? Okay, this is question number 12. Then 9, right? Next, question number 9. Question number 9. And someone asked about the workbook. Yes, I mean, the workbook given in the first day, I mean, it's nothing related to A-levels, okay? It's nothing related to A-levels, the first workbook. But I prefer if someone can try time to time, try to do at least one question from the first day workbook, okay? Sometimes to finish one question, it may take like 3 months for you guys, okay? The workbook is difficult, okay? The workbook is difficult, but it's nothing related to, attention everyone. It's the first day workbook is nothing related to A-levels, okay? But I prefer if you can like time to time try 1 or 2 questions from the workbook, it's really great. Why? The idea behind workbook is not to improve it's nothing related to physics, okay? It's nothing related to A-levels. At the end of the day, the students should be capable of thinking, okay? At the end of the day, students should be capable of thinking. So the main idea behind workbook is make sure that you like spend some time thinking things that are difficult, okay? That is the basic idea, and I mean that workbook is entirely developed using grade 6, 7, 8 questions in Chinese books, okay? In Chinese workbooks, grade 6, 7, 8. That's why Chinese people are there, okay? The workbook seems difficult, but it's from grade 6, 7, 8 books, grade 6, 7, 8 books from China. So that is the idea, okay? They have developed a generation of thinkers. We still learn stuff, study stuff, write exams, then it's done. We think it's done. No, it's not done, okay? We learn stuff, we pass exams, we go to university, but still we can't think. That's why there's very low amount of tech companies in the country. That's why we don't have enough inventions from the country, okay? It's the main problem. We develop educated people without training people to think, okay? So one of my main ideas is, I'm supposed to be an engineer, okay? So if I'm teaching, there must be a greater motive than, I'm doing engineering. Yes, I run on my own company. There are a lot of projects going there also. But if I'm teaching, there must be something, a bigger motive than just earning money, okay? Engineering domain has a lot of money than teaching domain. So if I'm skipping that, if I'm using that time to teach, there must be a better motive. So my main motive is I need to create a generation of thinkers if possible. Okay, we have a lot of people who know stuff, okay, who know stuff, knows theory, knows physics, pass exams, but we don't develop anything useful, okay, as Sri Lankans. Okay, we never develop stuff which is useful. Why? We don't develop thinking of students, okay? That's why Chinese people are there, okay? The whole workbook is from grade 6, 7 questions from China, okay? Now you see USA Olympiad team, entirely Chinese people. Canadian Olympiad team, entirely Chinese people. Chinese Olympiad team, entirely Chinese people. We don't have enough money to hire Chinese people. That's why our Olympiad team, we have Sri Lankans, okay? So that is the problem. That is the problem. Our people we never think, we never take thinking seriously. Okay, that's why we are here. Okay, so if I'm doing classes, one of the main motives is make sure that my students can think. Okay, then if we can create a generation of thinkers, there will be more tech companies, there will be more inventions. Okay, then the country will be nice. Okay, so that's why you will get time to time, you will get workbooks like that. I need you to, the questions are really difficult, but I need you to waste maybe 1 or 2 months trying one question. Okay, you won't get the answer even for after 3 months, but you were thinking, that process improves your thinking. Okay, that is the main idea. Okay, the more you think, it improves your thinking. Okay, at one point you will start to figure out everything. Okay. Yes, the workbook I'll again share in the WhatsApp group. And for students here also, if you don't have the workbook, we'll distribute that. It's difficult and it's nothing related to A levels. Okay, it's nothing related to A levels. It's just to make sure that you waste time thinking. Okay, workbook is there just to make sure that you waste some time thinking. Question 9. First thing, VA, VB. VA and VB. What is VA? 54 kilometers per hour. 54 kilometers per hour. VB, 36 kilometers per hour. Sorry? Question number 9. Which one? Sorry? Okay. A is 50. No, right? Yeah, A is 54. B is 36, right? B is 36. Yes, right? Confirmation? Correct? Yeah? 54 and 36, right? Yeah, anyways, we have to convert this, okay? It's in kilometers per hours, okay? Attention, everyone. People at the back, attention, everyone. So, I mean, attention in the sense you don't have to focus here, okay? If you get the answer, just do whatever the question you are doing, but you have to stay silent when I'm explaining, okay? So, VA, it's 54 kilometers per hour, 36 kilometers per hour, VB. So, first thing, we have to convert this into meters per second. Now, we know how to convert things to meters per second. You multiply by 5, divide by 18, right? Okay, that's what we took from the previous question, right? Clear? We derived this thing before, right? 5 over 18. That means 1000 over 3600. Clear? 1000 over 3600. Here also 5 over 18. Clear? Here also 5 over 18. Clear? Converting kilometers per hour into meters per second. 1000 over 3600. So I get here 15, right? It's 15 meters per second. Here it's 10 meters per second. 10 meters per second. I think that's what you mentioned, right? Okay. It should be 15 and 10 after converting them into meters per second, right? Clear? Okay. So what's next? First thing, we have converted things into meters per second. Clear? First thing, we have converted things into meters per second. Now I have the data set. Now I have to draw a perfect diagram. Okay. One of the main reasons to do mechanics questions here, some students may take the answer quickly, but I need you to draw a perfect diagram. Okay. So how can I draw the perfect diagram? Both A and B vehicles are 5 meters long. Okay, it's like this. It's like this. Now you have vehicle B like this. Now you have vehicle B like this. And vehicle A like this. Now you have two vehicles like this. Let's assume that vehicle B, A, passes vehicle B after time t, after time t. So, in time t, vehicle B travels a certain distance like this. Vehicle B travels a certain distance like this. Clear? Then at time t, now after time t, vehicle B will be like this. Vehicle B will be like this. After time t, vehicle B will be like this. Clear? Clear? This point will travel up to this point. Clear? If A passes B at this point, A should be like this, right? A should be like this. This is the meaning of passing, right? This is the meaning of passing, right? Is that clear? This is the meaning of passing. Initially, vehicle B was like this, A was like this. Now, passing means B is here after time t, A is here after time t, and this is the meaning of A passing B, right? Is that clear? Clear? Nice. Now we again know the definition of velocity. Velocity means displacement over time, right? Velocity means displacement over time. So displacement equals what? Velocity into time, right? Displacement equals velocity into time. So for B, I'll take the distance of B as SB. Velocity of B is 10. If time is t, it's 10 into t. Clear? If the distance traveled by A, I can take it using Vt. Velocity of A is 15 meters per second. Velocity of A is 15 meters per second. If time is t, it is 15t. Clear? So, distance traveled by B is 10 into t. Distance traveled by B is 10 into t. Clear? Distance traveled by A is 15 into t. Clear? Distance traveled by A is 15 into t. Clear? 15 into t. Then, what is the length of a vehicle? 5 meters, right? Then this is 5 and this is 5. Now see, a perfect diagram holds a lot of details. A perfect diagram holds a lot of details. Clear? Why? Now see, 15t equals 5 plus 10t plus 5. Clear? 5 plus 10t plus 5. Clear? So 15t equals 5 plus 10 into t plus 5. Clear? 15t equals 5 plus 10 into t plus 5. Yes, if you understand relative velocity, this is just a 1 second question. Okay? I mean, when you are doing mechanics, if you are good at mechanics, this is just a 1 second question. But I need you to draw a perfect diagram like this. Why? Again, sometimes the mechanics questions, you have a whole page of data. It's a whole paragraph. Attention. You have a whole paragraph. Okay? So you can't just read the paragraph again and again. You must have that skill of converting paragraph into a perfect diagram. Okay, whenever you are working in A levels, you must have that skill set of converting a whole paragraph into a perfect diagram like this quickly. then you can forget the paragraph and do the whole question using the diagram. Okay, it's not for questions like this, but we have to start with the questions like this. Okay, we have to draw a perfect diagram for every question so that you have that habit of drawing a perfect diagram quickly. Okay, it's really important. See, now this contains the whole equation required. You don't even have to think if you draw the proper diagram. Clear? If you draw the proper diagram, you don't have to, the amount of you have to think gets reduced if you have a proper diagram. Clear? Now just by this diagram you can see 15 into t equals 5 plus 10 into t plus 5 equals 15 into t. Clear? So I get 15 into t minus 10t, that means 5t equals 5 plus 5, 10. Then t equals 2 seconds. T equals 2 seconds. Clear? That is the time taken for the process. Then at that time, the distance traveled by B is 10 into 2. T is 2. Here it's 15 into 2. B travels a distance of 20 meters. A travels a distance of 30 meters. Clear? Clear, everyone? This is the idea. See, a perfect diagram is really strong, okay? It contains a lot of information which you can easily use, okay? Okay, you can try other questions. Let's return back to units and dimensions. Okay, so there are things like this. Yeah, I'll give it to next week. You can try because it needs time. It needs time, but if you want the answer, I mean, you can stay after the class. I'll explain. Okay, it's a difficult question, by the way, right? It's a difficult question. You have to use moment for the question. You have to consider moment for the question. You rotating something around, that means you have to use moment. If someone's trying question number 23, it's difficult. It's related to moment, okay? And if you can't do the question, just don't worry, okay? You will learn it in mechanics, okay? You will learn these things in mechanics. I just need you to be uncomfortable, this is, attention everyone. This is related to, anyone, like most of the students here, if you are doing bio, are planning to be maybe doctors. Most of the people who are doing maths are planning to be engineers. Okay, so you should be comfortable with the unknown. Okay, even last week we got a project from California, my company. It's something like, can you remember Jarvis, Iron Man in Iron Man? Okay, they have a camping rig. They must be able to control that camping rig using mobile app, but in that iPad app, they should see the 3D diagram of the whole camping rig inside and out. So they should be go inside or out and press a button, like press a light, then that light should be on and off. They should be able to open doors, close doors, control everything inside and out of a camping rig using the app. And it should be available sound controls and all. So we just agreed for that project. It was around maybe, it's around 80 or 90 lakhs. The project price was just to build an app, okay? So it's quite beneficial for us, the company, because no hardware cost, just preparing the app. It cost 80, 90 lakhs, but still we don't know how to do that, okay? Still, we have already signed contracts and everything signed. Still, we don't know how to do that. Now we have to figure out. That's what it's about doing engineering, okay? You have to be able to try to figure out, do something. Research for hours, maybe research for days and figure out something, okay? So even it same goes for doctors, okay? If you are just going to, I mean, if you are going through a mental instability after seeing your first patient dying, okay, then how the hell you are going to be a doctor, okay? So it's all about like working with the unknown, being comfortable when you are working with something that you have no idea. That's what is about to be a science. That is the basic meaning of doing science, okay? That's what it means to be doing science, okay? So you can't just cry or be weak after going through one or two difficult questions, okay? You can't just, fall apart after getting low marks in one or two papers, okay? That's what it means to be an engineer or a doctor, okay? So yes, it matters, okay? So that's why I'm asking you to do these difficult questions. You will all okay for A levels, if you are not able to do these questions, no big issue. There are lessons. We teach these things separately. Okay, so it's not about A levels. Okay, it's about I need you to just try questions which feels uncomfortable, which you have no idea how to do that. Okay, that's what it means to be an engineer or a doctor. Okay, first understand the meaning of what you are doing. Okay, okay. So it's not about getting the correct answer. It's keeping your mental stability and doing a hard question. You still don't get the answer, but you still try. You still don't get the answer, you still try. That's the whole process of building a proper engineer or a doctor. Okay, let's continue. Attention, everyone. Attention. Methods of expressing the SI units. So these are very fundamental stuff, okay? These are very fundamental stuff. I'm mentioning these things because they ask us to mention, but these things, basically it's common sense, okay? Most of this stuff are common sense. Methods of expressing SI units. One thing is, if it is related to a name of a scientist, attention everyone, if it relates to a name of a scientist, it should be capital. Kelvin capital, Ampere capital, Pascal capital, Hertz capital, okay? When we are doing papers by next week and when we are doing the workbook, you will understand what is capital, what is not capital. When you are getting some questions wrong, you will understand it properly, okay? So Kelvin, Ampere, Pascal, Hertz, everything is capital Y. These are people, okay? These are people. Then you don't have plural, okay? You don't have plural in units. It's 5 kilograms, okay? But it's 5 kg, not 5 S, okay? There's no plural form, okay? There's no plural form here. And yes, attention, multiple or a submultiple means, K means 10 to the power 3, okay? K means 10 to the power 3. That doesn't mean you can write multiples anywhere you like, okay? Okay, that means this is okay, 5 kilograms, okay? But this is not okay, okay? Okay? You can write k wherever you like and assume that you have 10 to the power 3 there, okay? Multiples and submultiples should be here, okay? Before the unit, before the main unit, clear? Okay. Then, uh, then there's no gap between the main unit and the prefix. That means it's something like this. Kilograms, these two must be close. You can't keep a space between kilo and grams. Okay? You don't keep a space between kilo and grams. But different units, you keep a space. That means this is multiple and the unit, right? This is centimeters, you don't write like this. They should be close to each other. Clear? They should be close to each other. Multiples and submultiples must be close to each other. Clear? But Newton meters, proper way is not this one. There must be a gap. There must be a gap. Clear? Kilogram per meter cube, there must be a gap. So that we know that this is a separate unit and this is a separate unit. But I mean, you don't have to follow these things when you're writing, okay? In a mechanics question, you have more than enough trouble to face, okay? You have more than stuff to think. So you don't have you don't need to waste time thinking, okay, whether I have to keep a space here or not, okay? So just forget these things when you are doing a bigger question. But if it is a question which is related to units and units only, sometimes in A levels, you get one MCQ, first MCQ from units. So that question is related to units. If that question is entirely related to units, then you have to consider these things. If a question is entirely related to units and units only, then this is wrong, this is correct. Clear? But if it is a mechanics question, if instead of writing this, if you write it like this, anyways, you are going to get marks, okay? Nobody cares in a mechanics question. Nobody cares whether they are close or not, okay? Clear? So these things you have to consider when you are doing a entirely a units and dimensions question. Otherwise, just don't waste time keeping space here and there, okay? Just write the unit, okay, as it is. Clear? So this is the proper way. There must be a space in different units. You can't keep a space between multiples and submultiples. Clear? Then, again, there must be a space between the numerical value and the unit. 5 newtons, it's wrong. It should be 5 space newtons, okay? 5 space newtons. There should be a gap between the number and the unit. And here also, same concern, okay? If it is a units and dimension question, you think about this thing. If it is not a unit and dimension question, you just forget it, okay? Clear? Next one. And just you can't use multiples and submultiples more than once, okay? That means this is micrometers. That means it's 10 to the power minus 6 meters. This is not 10 to the power minus 12 meters. It's wrong, okay? Clear? You can't use like 5 micros to write 10 to the power minus 15 or something like this, minus 30 or something like that. No. It's micrometers, okay? Nanometers, kilometers. Clear? You can use them only once. We are mentioning these things because they have asked us to mention these things. Otherwise, most of these stuff are common sense, right? Clear? Okay. And again, although we use the although we use this units SI system, some industries still use their own units, okay? I mean, NASA, they speak in light years, okay? They don't care about mentioning stuff in meters, okay? Why? Meters is too small to mention things related to universe, okay? So they use light years. Light years means the distance traveled by light in 1 year, right? Distance traveled by light in 1 year, clear? So they always mention stuff using light years, okay? Clear? And shoe size, UK shoe size, you're not gonna go and tell that your shoe size is maybe 12 centimeters, no, right? It's 50 UK, 40 UK, 7 US. So these are industry specific stuff, okay? So usually this UK measurement is related to a size of a barley corn or something like that, okay? They were entirely dependent on that industry, okay? These are historical units, okay? But still we use them, okay? Shoe size UK. Things related to space, light years, okay? So we can't get rid of industry specific stuff, okay? There are industry specific units, although we prefer SI units, okay? You have more, that kilowatt hours, we call it units. Units. Where do you see this term units or kilowatt hours? In your electricity bill, right? Who have seen your electricity bill? Have seen your electricity bill? Really? You haven't seen your electricity bill? Others? I mean, just have seen, just go through your electricity bill. I mean, seen in the sense like looking at it from a distance, I'm not talking about that, okay? Who has read your, I mean, have you go through your electricity bill? Okay, okay, you can forget that. Okay, attention. So electricity bill, it's mentioned in number of units. Number of units. What one unit means? 1 kilowatt hour. Kilowatt hour we use to measure energy. Kilowatt hour we use to measure energy. What is kilowatt hour? 1 kilowatt hour means, kilowatt means power, right? It's the energy consumed by an instrument which consumes or which has a power of 1 kilowatt in 1 hour. 1 kilowatt hour means energy consumed by something with a power of, with a power of 1 kilowatt, with a power of 1 kilowatt, maybe a motor with a power of 1 kilowatt in 1 hour. Clear? It's kilowatt hours. It's also a industry specific unit, okay? We call it units. They directly mention your electricity bill is 50 units, 40 units, 30 units. They don't mention joules, kilowatt hours, nothing. It's 15 units. These are industry related stuff. Clear? Okay. Then we have to learn general features of units, okay? We have to learn general features of units. Okay, attention. What are the general features of units? Units cannot be added. You can't add units. That means 5 kilograms plus 2 kilograms. It's not 7 kilogram, right? It's just 7 kilogram. Okay? It's just 7 kilogram. Okay, you can't add units. Okay? But to add two quantities, their units must be equal, right? Another requirement. You can't add 5 kilograms with 2 meters, right? Okay. To add physical quantities, the units must be equal. Same goes with subtraction. 5 centimeters minus 2 centimeters, it's 3 centimeters. That's all. Okay. But you can't subtract 2 centimeters from 5 kilograms. Okay. It doesn't work like that. So unit must be equal to add or subtract. But in multiplication and division, that's not the case, right? In multiplication and division, it's a different story, right? Why? You can multiply anything, you can subtract anything, divide anything. Why? Units can be multiplied, units can be divided, right? That means 5 kilogram into 2 meters, you get 10 kilogram meter. Clear? Units can be multiplied. Clear? Units can be multiplied. 5 Newton over 2 meter squared, you get 2.5 Newton per meter squared. Units can be divided. So you don't need equal units, anything like that. Why? Units can be divided or units can be multiplied, okay? You don't have a requirement like the units must be equal to multiply. No, there's no such issue. Clear? Attention, everyone. Attention. So there's no such issue. Clear? Okay. Then what next? What's next? For an equation to be correct, units must be equal. That means, let's take an equation that you know, F equals M, sorry, P equals H rho G. P equals H rho G. Units must be equal. That means, what is P? Pressure. We found the unit of pressure. Can you remember? It was kilogram per meter per second squared, right? We derived this before, right? Can you remember? Units of pressure. Here take H. What is H? Height. That means meters. Rho means density. Density means kilograms per meter cube. Density means kilogram over meter cube, right? Density means kilogram mass over meter cube. Clear? G. G is gravitational what? Acceleration. It's an acceleration. What is the unit of acceleration? Meters per second squared. Clear? Meters per second squared. Clear? So what do you get when you solve this? You get kilogram. Here m cancels out. You have 1 m remaining per meter per second squared. See? Units must be equal. Clear? So for an equation to be correct, units must be equal. Then for an equation like this, P equals A plus C over B, something like this. What is the requirement? For me to add this one and this one, unit of this one and unit of this one must be equal. If this is meters, this must be meters. When I add meters and meters, I get meters. So unit of this one also should be meters. So if you have an equation like this, clear? If you have an equation like this, unit of this part must be equal to unit of this part, must be equal to unit of this part. Clear? Unit of all three parts must be equal. Clear? Clear, everyone? Okay. Then, what else? What else? You can't have a unit as a power, okay? There's no meaning in this statement. 5 to the power 2 kilograms. This is meaningless, right? You can't figure out a meaning for this, right? Clear? So, power must be unitless. Clear? A power must be unitless. Okay? For you to add 2 terms or 3 terms, they must have the same unit. For an equation to be correct, both sides must have the same unit. Then, a power can't have a unit. Clear? So, it's 5 to the power 2 kilogram, not possible. Clear? Here, it should be 5 to the power 2. That's all. Clear? So, a power must be a numerical value always. Clear? A power must be a numerical value always. It can't be a unit. Clear? Clear? It can't have a unit. Then again, result of a sine cos value can't have a unit. That means sine something must be unitless. Why? Sine something must be unitless. How do we derive sine? How do we derive sine cos tan? Length divided by length, or length divided by length. Again, length divided by length. So when you divide length by length, it's unitless, right? If this is 5 meters, if this is 2 meters and this is 5 meters, it's cos means 2 over 5. Meters to meters cancelled out, so it's unitless, right? Sin theta is unitless, cos theta is unitless, tan theta is unitless. Why? We get them by dividing units. Clear? So, sine value of anything can't have a unit, okay? Sine value of anything can't have a unit. Clear? I mean, why do we learn these things? These things are quite helpful in some certain situations. Why? In A levels, you get 50 MCQs, okay? 5 answers per each MCQ, okay? There's a lot to think there. But sometimes when you check 5 answers, you can see 3 or 2 answers, okay? They don't give you the correct unit. One answer, it's when you can, it's unit wise wrong. Okay. So if, there may be huge difficult question related to mechanics, but you can remove certain answers just by checking the unit, okay? Just by checking the unit. So in such issues, you don't have to do any calculations in certain situations just by checking the units or just by checking whether the answer follows the basic rules related to units. Just by checking that, you can eliminate some answers and find the correct answer without doing any calculations. So when you are doing MCQs or to check your answers, this common sense related to units, how they work, where can you have units, where can't you have units, this common sense related to units, it's really helpful, okay? That's why we are learning units here, okay? That's why we are, otherwise we don't have to mention, right? Anyways, 5 kilograms, you can't add 2 meters with 5 kilograms, you know that, right? Okay? But that's why we are mentioning them, okay? It sometimes help us to get answers for different questions, okay? Clear? Clear, everyone? Okay. So, and also that the session for bio students will be starting from May, okay? There will be a separate online session weekly for maybe 4, 5 or 6 weeks for bio students to teach certain maths parts which that they are gonna miss because they are not doing maths, okay? So these parts will be explained in that session, okay? We'll start by May, in May. Okay. So, is this clear? And again, attention everyone, again, log value, log function. You can't put anything with a unit into a log function. Attention, attention everyone. You can't put anything related to a unit into a log function. That means log value of 5 kilograms, meaningless. Log value of 2 meters, meaningless. You can't put anything with a unit into a log function. Okay? Then result of a log function again can't have a unit. Log 5 can't be 2 kilograms. Okay? Result of a log function can't have units. Clear? Is that clear, everyone? So, why do we learn these things? I'll explain you. Why do we learn these things? Try this one. P equals A 5 to the power A T. Find the unit of P. Find the unit of P. Unit of T is seconds. It's time. T is time. T is time. T is time. Find the unit of P. Now we should understand why do we learn these things. Let's do a lot of questions like this, then you will understand this thing properly. I'm just doing a demonstration here. We learn these unit related, attention everyone. We learn these unit related stuff because sometimes in science experiments, we get a result. We know that there are certain quantities here, there are certain physical quantities here, but we don't know the result of the physical quantity. Okay, we don't know what is the physical quantity we are going to get, but we can analyze the physical quantities of the things that we know. Then figure out the physical quantity that we don't know. Clear? So in analysis, we need this stuff. Okay, using this, I'll explain you this thing. Okay, what is the unit of P? S minus 1, correct. Why? Why? See, now follow the rules. You have an equation like this. A power can't have a unit, right? A power can't have a unit. So multiplication of A and T can't have a unit. Clear? They can't have a unit. Okay? So I'll just write it like this. This thing can't have a unit. Clear? So unit of A is UA. Unit of T is seconds. Unit of time is seconds. Is unitless. When you multiply these two, there's no unit. Clear? Then unit of A is 1 over second. Clear? If A is 1 over second and if T is seconds, then they will cancel out and it will be unitless. Clear? Clear, everyone? So here, a power can't have a unit. Clear? Since here we can't have a unit. If t is in seconds, a must be in 1 over seconds. Clear? Then this part won't have a unit. Eh? Why? It's 5 to the power something. It's just a number, right? 5 is a number. Number to a power something don't have a unit, right? If this is 5 to the power something, it will be 15 or 25 or 100 or something without a unit, right? A numerical value, a power of a numerical value can't have a unit, right? Clear? So this part, it's entirely unitless. Clear? 5 to the power something, it's unitless. Then unit of P equals unit of A, right? Since this is unitless, unit of P equals unit of A. Clear? Then what is unit of A? 1 over seconds. That means per second. Clear? See, we learn these rules to these kind of analysis, okay? We learn all these rules to do these kind of analysis, okay? Then in certain equations or different scenarios, we know where can we find a unit, where can't we find a unit. We can figure out, if we don't know this physical quantity, we can figure out what is this physical quantity, what is the unit of this physical quantity, okay? We can figure out these things, okay? That is the basic idea. Clear? Try this question. T is measured in seconds. T is measured in seconds. B is measured in meters. B is measured in meters. Find the unit of P, A, and R quickly. And I remind reminder for online students, just set up your website, set up your account in the website. I'll provide all the details in the group. And next week, if possible, be here by 1:30, right? 1:30 to 2:30 or 2 to 3. You can write the paper, then stay in the class directly. Then you will get the marks after the class, okay? You will directly get your paper, marked paper after the class. So it's just one day we are done with physics, okay? It's a complete class then. Paper, theory discussion, and your answer, corrected paper. I'm just trying to create a perfect class. I mean, I've been trying to do this for years. So now I'm trying to figure out that thing. And I repeat, writing the paper is not mandatory. It's good for you, but I mean, I can't force you to write a paper, okay? So it's not mandatory. It will be really beneficial in the first term test and in A levels if you write the paper every week. But if you can't write the paper at the given time, let me know. I'll arrange around the time slot, maybe after the class at least. Online students, you will get the paper at the same time through the group, okay? There will be a submission link. You can submit your answers and automatically the answers will be marked. Yeah, definitely. It's a good question. When you have schools, we can't write the paper from 2 to 3, right? So you have to leave the school around 1. I mean, in our time, it was possible to leave the school around 1 or 12:30. You wear something, a colored T-shirt, you go out of the gate. That's all. So for us, I mean, even now, every boys' schools have a gate at the ground, right, where you can leave whenever you like and when you can return whenever you want. Isn't it available? At least in our school, Anand? No? It's still there, right? Any Anandians? Yeah, it's still there, right? Whenever you like, you can leave. Whenever you like, you can return. If the security person is okay with you. So, okay. So, I mean, every day I did that, okay? Whenever I like, I go to school. Whenever I like, I go to my maybe table tennis room or washroom. I would have colored and I leave school. So it's not a good thing, okay? Just don't try these things, okay? Not advices, okay? Whatever I did is not advice, okay? So, uh, attention. So when school starts, definitely let's go with another plan. Maybe if it is possible for everyone, we can delay the class maybe by half an hour or 1 hour, then put the paper there. So maybe 2:30 to 3:30 or 3 to 4 paper, 4 to uh, 5, 6, 7, around 7 class, something like that. Let's arrange something like that. So when school starts, plans will be changed a bit. Okay. So attention everyone, attention everyone, attention. Anyways, just don't start a class after the, I mean, don't start a new class after this class, okay? If whatever individual classes, anything, just don't arrange it after this class. Why? Whenever I feel like I should do practicals for you guys, or if we need to revise something, those sessions will be after this class. So if you have nothing after this class, it would be really convenient for you guys, okay? Okay, attention everyone. I'll finish this. It's P equals A plus B log T over R. So as I explained, this part can't have a unit. You can't put anything with a unit into a log function. Clear? So T over R can't have a unit. T over R can't have a unit. Clear? You can't put anything with a unit into a log function. It's wrong. So if T is in seconds, R must be in seconds. Then seconds to second cancels out. T over R becomes unitless. Clear? Whatever you put into a log function, it can't have a unit. Clear? So if T is seconds, R must be seconds. Clear? So the unit, attention, of R is seconds. Clear? Then result of a log function can't have a unit. Can you remember? Result of a log function can't have a unit. If the result of this one is 2.5, it's just 2.5. No unit. So result of a log function can't have a unit. Clear? So this part doesn't have a unit. Then what is the unit of this part, this whole part? What is the unit of this whole part? If this is unitless, if this is meters, it is meters, right? Meters into something unitless, final answer is meters, right? So this whole part, unit of this whole part is meters. Clear? Clear? Unit of this whole part is meters. So you can add only meters to meters, right? If this part is meters, this is meters. If this is meters, this is meters. Clear? If this whole part is meters, then this is meters, then this is in meters. Clear? That is the idea. Okay then. So let's stop for today. I mean, you don't have a lot of homework. Try whatever the questions you like. Okay, that's all for today. Thank you.